Hey guys, welcome back to General Chemistry. The next periodic trend that we're going to talk about is ionization energy. So this is kind of a series of 3 videos. We talk about atomic radius, we talk about ionization energy, we talk about metallic characteristics. This one is ionization energy. Before we can look at the trend, let's define what ionization energy is. So ionization energy is the amount of energy required to remove an electron. So we've got these neutral atoms. We've alluded to the fact that they are going to lose electrons. They are going to gain electrons. That's something that happens during the chemical process. But there's an energy associated with losing those electrons, and that is ionization energy. So how much energy is required to actually take one of those electrons away? Again, we're going to look at 2 trends. We're going to look at trends top to bottom, and we're going to look at trends left to right. So let's first start top to bottom. And we can look at the noble gases, I suppose. That's probably the easiest one to see here. So if we look from top to bottom in our noble gases, what we notice is that ionization energy decreases. So a number that is high ionization energy, that means it's going to be really hard to take that electron off. I'm going to have to work really hard. Something that has a low ionization energy is going to be a little bit easier to take it off. Like I'm still going to have to work to take it away, but it's going to be a little bit easier. So that's how ionization energy works. So looking at the noble gases from top to bottom, we have high ionization energy to low ionization energy. So why might that be the case? It has to do with those orbitals again. So for helium, the valence electrons for helium are very, very close to that nucleus. So remember, there is an attraction between those protons in the nucleus and the electrons in the valence shell. So there's going to be that kind of magnetic attractive force between those two. So if it's really close to the nucleus, like it is in helium, it's going to be really hard for me to take that electron away. It's not going to come off very easy. But if we go down the periodic table, down to radon, it'll be a little bit easier for me to take that electron. Why? Well, because it's a little bit further away from the nucleus. So now, while the protons are trying to reach out and attract those valence electrons, now they have to reach through 6 energy levels to get there. So that interaction isn't as strong, and it's going to be a little bit easier for me to squeak in there and take an electron. So from top to bottom, the ionization energy decreases because those valence electrons get further away from the positively charged protons. Now we're going to look at the trend from left to right. So the trend from left to right, generally, there are some exceptions here, but the trend from left to right, generally, ionization energy increases. So if we look at lithium over to neon, generally that's an upward trend. Why? Well, think about what these atoms are doing and how many valence electrons they have. So if we think about fluorine right here, fluorine has 7 valence electrons. Fluorine is trying to be like neon and have 8 valence electrons. So fluorine is going to beg, borrow, and steal. He's going to do anything that he can possibly do to steal 1 electron. Now, if I walk up to fluorine and I say, give me one of your electrons, do you think he's going to be apt to give that away? No. He's trying to steal one. He is certainly not going to want to give one away to somebody else, and he's going to fight really hard to keep it. So fluorine is going to have a very high ionization energy because he doesn't want to give up that electron. Now, if we go back over here to lithium, how many valence electrons does lithium have? Yeah, lithium's got 1 valence electron. And it turns out that lithium's actually pretty okay with getting rid of that valence electron. If he gets rid of that valence electron, remember he goes down in energy level and his valence shell is full down there. So he's kind of okay with giving up an electron. So that's why the ionization energy for lithium is going to be particularly low, because he's like, meh, take it. He's not going to put up much of a fight. I got to work a little bit, but he's not going to put up much of a fight. So ionization energy going from left to right generally increases. Those atoms tend to be less likely to release their electrons. That's it for ionization energy. I hope you guys found this helpful.